Hi! In this series, we'll be going through the H2 A-Level Mathematics 2021 Paper 1. Let's begin. For question 1, it gives you a bunch of information and we're supposed to find the values of A, B, C, D, which are the coefficients of these functions. And since that there are 4 unknowns, we actually need 4 equations to solve them. And so, we already got the first one, where we just sub in 1, so you get A plus B plus C plus D equals to 5. Then we sub in minus 1, so it's minus A plus B minus C plus D equals to minus 3. So the first two is fairly straightforward. Next, we tell you that the turning point is at x equals to 1. So we need to find dy dx equals to 0 at 1. So you just differentiate this, which is just 3ax squared plus 2bx plus c. Sub in 1, so it's 3a plus 2b plus c. It must equals to 0. And then they tell you the integral equals to 6. So similarly, you integrate fx and sub in the according values, and this should be 6. So now with 4 equations, you can use your GCE, put into the simultaneous equation solver, and you'll get that a equals to 4, b equals to minus 6, c equals to 0, and d equals to 7. So this question is fairly straightforward, and there shouldn't be trouble. But if you have, you can leave it in the comments. I will make sure to answer them. For 2 part A, we're now practicing on sketching the graph. And so, for the modulus graph, initially without the modulus, it will be something like that. So with the modulus, this flips over, meaning this part is actually a 5 minus x squared. And then you just draw the 2x minus 1, and then you use your GC to find the intercept. So you can just use your GC to plot how it looks like first, and then this intercept should be easy to find. Next, we're supposed to find now the exact solution. So your GC can only give you a rough estimate. To find the exact solution, well, we can just equate these two accordingly. For this part of the graph, it is actually x squared minus 5 equals to 2x minus 1. So we just solve for it and reject the part that is less than square root 5. So we reject the negative in a sense. And for this intersection, it's 5 minus x squared equals to 2x minus 1. So you can use the graph to help you see which functions are actually getting equated together. With that, you can again use the quadratic formula to get minus 1 plus minus square root 7 and reject the according solution that is negative. So it's actually minus 1 plus square root 7 and 1 plus square root 5. Moving on, question 3 is a differentiation question, and so we are given an equation of a curve, and we're supposed to show that dy dx is that. So we just need to differentiate this accordingly. So we just bring down the power. X1 minus the power minus 1, and similarly for y. But because this is not in terms of x, we have to use the chain rule to multiply dy dx. So then you just bring this over, divide by this, and you should get what the required answer is. Next, we are supposed to find the equation of the normal to the curve at x equals to 1. So this is how you apply what you already know. So the first part tests you on chain rule, and the second part tests you on application of differentiation. So x equals to 1, y is 4. This allows us to now sub into here, because this is y and x, to find the gradient of the tangent at that point, which is minus 2. And so the normal is minus 1 over gradient of tangent, so it's actually half. Then the equation of normal, now you can find it as y minus y1 equals to m bracket x minus x1. M is half. Then you just set in x1 as 1, y1 as 4. And simplify, you should get y equals to half x plus 7 over 2. So the first 3 questions are, you should be able to do it quickly because you need the backfill will probably be more tedious. So we try to do it quick and accurate. For question 3, we're given this complex number that looks really difficult, but actually the best way to do complex numbers is always do it in exponential form, as it really simplifies the question easier and you can treat them as like vectors. So what is the mod x? Well, we know z is this weird complicated looking thing. The first part can be written nicely as e to the power I pi over 16, and the second part is e to the power I minus pi over 8. This will allow us to say this is when the 2 comes in, it becomes pi over 8. Pi over 8 minus pi over 8. So that is pi over 4. So quickly you can get this form. And with this form now, you can immediately say what is the argument and modulus. The modulus is this coefficient, which is 1. And the argument is pi over 4. So z squared now is you just take this squared and this will become a 2 then. So you just use your so ei pi over 2 is what? Well, you got this. Pi over 2 is on this y-axis, imaginary axis. So it's just I. And for part B now, we are supposed to do some manipulation to get what we want. With this, yes, you can convert cosine theta plus I sine theta as ei theta, or you can just expand out normally and you actually see that the terms cancel out. So this I sine cosine theta will cancel out with this, and then this 2 will become 1, and you're done, essentially. In the last part, they ask you to use hence or otherwise. For me, the otherwise is much easier because what is the conjugate? Well, one thing to remember is that if the modulus is 1, the conjugate and reciprocal are actually equal. Because if you see the conjugate is this, then the reciprocal is also this. Because what's z? Z is ei theta, right? Let's say 1 over z equals to ei theta whole thing reciprocal, but this just multiplies in, so it's actually ei minus theta, which is actually equals to z conjugate. So actually over here, what you can do is you pull out the z. This is 1 plus 1 over z, which is actually z conjugate, which is the same as this. Then you can group them together to power 4, and this is 1 plus z4. Now you know z4 is actually over here, you already find is I. So z4 is actually minus 1 because I squared is minus 1. So this is minus 1. So this part is 0. You don't even need to care about this and result in getting 0. So you actually don't need to use the hence always. Sometimes the hence is just to allow you to see how you can apply your different algebraic formulas. But if the otherwise suits you better and you can understand it more, you should just use for otherwise. Because in the exam, you'll be time tight and you'll try to do the paper as quickly and as accurately as possible. That's all for this video. I hope you have enjoyed the first 4 questions of the paper. We'll be continuing in the next video the rest of the question, so stay tuned. Please like, share and subscribe, and turn on the notification bell for updates about this series. Bye!